aspirants. Today we'll start a new chapter that is our fourth chapter. It is cubes. And if we talk cubes in terms of logical reasoning, so we have to visualize a lot. So before that, let's check certain key properties of cubes which are very much important in this topic. On my left, you can see there is a single pink color cube, and on my right, there is a Rubik cube with multiple colors. So certain properties like we can see there are corners, we have edges, and we have faces. Now, if we see about corners, this is a corner. So a cube has total 8 corners. Talking about edges, these are called edges. So we have total 12 edges in a cube, and this is the face of a cube. We can see there are 6 faces in total. So this three basic properties are very much necessary. If we are through with this, it will be very much easy for us to solve any type of questions. So after finding out the properties of cubes, what we'll do is we'll study cubes in three parts. The first part will consist of cuts and pieces. The second part will be covering face paints, and in that we'll have subparts, that is opposite case, we'll have adjacent, and the third is the mixed one. It's a mixture of opposite and adjacent. And the third part will be miscellaneous, where we'll be discussing about diagonal cuts and enlarging the cube. But before that, we have to understand that the tone of the question will always be like a larger cube is cut into smaller pieces. Now, they could have said that a larger cube will be cut into smaller cubes. But what happens is that while making cuts, it's not necessary that the smaller pieces will be in form of cubes. It can be in the form of cuboid also. So that is the major reason they will use the tone as larger cube is cut into smaller pieces. Now, one more thing is added into this, that the larger cube is cut into smaller but identical pieces. The two terms here is specifically used, that is identical and pieces. Now, the reason for pieces is because it is not necessary that the larger cube is cut into smaller cubes. It can be cut into pieces also of cubites. So it can be cube or cuboid. Hence, they use this term pieces. And to have that identical pieces, the term used as identical is because one will have to make cuts in a proper pattern. You cannot make diagonal cuts or you cannot make any wayward cuts, because if you do that, you will not get pieces, all the pieces of same shape and size. You will be required either cubes or cubites, and for that you will have to have identical pieces. And to have that identical pieces, the cuts the cuts are made on the axis, or you can call it planes, or you can call it directions. So the cut will have to be made on the directions, the three directions or the three planes, you call it as x-axis, y-axis, and z-axis. Like here is the cube. The cuts will either be on this direction, or this direction, or on this direction. So these are the three directions where cuts can be made. No other pattern will be involved here. So as we have discussed that the cuts of pieces, what term is used here is identical pieces, and to have that identical pieces, we'll have to make the cuts on the planes. So we'll have three planes here, that is x, y, and z axis, x axis, y axis, and z axis, as we have discussed it earlier. Now I will be having three different patterns to make this identical cuts. First, I can make all the cuts on only one axis. By making cuts on only one direction, I can have identical pieces. My all cuts will be on either x-axis, or on only y-axis, or on only z-axis. Through this, I will be making cuts in only one direction, and all the pieces will be identical. My second case will be, I will be using any two directions for the cuts. My cuts will be on x and y axis, or they can be on y and z axis, or they can be on z and x axis. So the cuts will be made on two out of three directions to have that identical pieces. And my third pattern will be, I can make cuts on all the three directions, that is x axis, y axis, and z axis, to have that identical pieces. Now all the three patterns are valid and they will give you identical pieces. But we'll have to see the difference between the three type of cuts which we have discussed here, because there will be no difference in the shape of the cubes or the shape of the pieces or the size of the pieces, but there will be a difference in one thing. That is, for example, let's give a name for the number of pieces, that is 8. So I'll have to make 8 pieces from a larger cube. Firstly, I will make two cubes here, and as I know the number of pieces I will have to make is 8, so I will make 8 pieces from the first pattern, that is the cuts on only one direction. So we'll make the first cut here, first, second, third, fourth, fifth, sixth, and seventh. So we'll have 7 cuts on one direction, and I will check how many pieces we have got. We got one piece, two, three, four, five, 6, 7, and 8. Now to have 8 pieces, I'll had to make 7 cuts on one direction. Now we'll go with the third pattern, that is the three directions. So I'll make one cut here. We'll have 2 pieces. One cut on the second direction. We'll have 4 pieces. That is 1, 2, 3, and 4. And I will make one more cut here. That will be 8 pieces. Now we have discussed all the three different patterns to make cuts, but here the difference is not in the shape or size. The difference is in the number of cuts made. So minimum cuts will be required when I will use three directions, and maximum cuts will be required when I will use one direction. So this is the main concept here. And please understand that if there is a question that a larger cube is cut into n number of pieces and how many cuts are required, so answer will be cannot be determined. As we have discussed it now, there can be either maximum cuts or minimum cuts to make that n number of pieces. If maximum and minimum is not asked, the answer will be cannot be determined. So now we know that the number of cuts can be either maximum or minimum. So we have a number here. Let's do a question that if a larger cube is cut into 125 smaller pieces, what can be the maximum number of cuts required to make this 125 pieces? Or what can be the minimum number of cuts required to make this 125 pieces? So we know that the maximum number of cuts can be when we'll make all the cuts in one direction, and the minimum number of cuts will be when we'll make the cuts on three directions. So to have 125 pieces on three direction, I will have to make 5 pieces in one direction, 5 in the other, that will be 25 pieces, and 5 in the third direction, that will be 125 pieces. Now to have this 5 pieces, let's say we have a plank here, and whenever we have to make this plank in 2 pieces, what we'll do is we'll make one cut here. So with one cut we had made 2 pieces. Now if I want 3 pieces, I will make one more cut. With 2 cuts I have 3 pieces. With one more cut, that is 3 cuts, I have 4 pieces. So the relation between cuts and pieces is of 1. The difference between both of them is of 1. So from cut to pieces will be +1. From pieces to cut will be -1. So here I have 5 pieces. Now for 5 pieces, I will have to make 4 cuts. For 5 pieces, 4 cuts. And for here 5 pieces, we'll have to take 4 cuts. So 4 cuts in each direction, that will be 12 cuts. The total number of 12 cuts are required to make this 125 pieces. And if we see about maximum, that will be on one direction. So the number of cuts will be 124. So maximum cuts and minimum cuts, the pattern to solve maximum and minimum cuts is this. One thing we have to realize is the difference between cuts and pieces. It will always be 1. It will not be 2. It will not be 3 or 4 or 5. The difference will always be 1. Let's say they have said 7 pieces, then the number of cuts will be 6. 5 pieces, the number of cuts will be 4. 3 cuts, there will be 4 pieces. So from pieces to cut, -1. From cuts to pieces, that will be +1. Let's take one more example. 512 pieces, maximum number and minimum number of cuts. So maximum cuts will be 512 -1, that will be 511. For minimum, you will have to divide in 3 parts, that is 8 into 8, 64, into 8, 512. So we'll have -1, minus 1 and minus 1, that will be 7 plus 7 plus 7, that will be 21 cuts. Okay, so far we have discussed questions on a perfect cube. Let's say I will take an example of 100 pieces. Now what happens is 100 pieces. So 100 is not a cube. Right now what we did was we did a question on 125, so it was easy for us. 125 is a cube of 5, so we made 5 5 5. 512 was a cube of 8, so we did 8 8 8. But 100 is not a cube, so we cannot divide it equally in three parts. But that does not mean that if you have to make equal number of pieces, you will be using two parts of 10 into 10, because in that case 10 into 10 will be giving 100 pieces, but the number of cuts will be 18. For 18 cuts we had made 100 pieces, but in a question where we had to find 125 pieces, we used 12 cuts. So this cannot be the case of minimum, it will be contracting the conditions, the major condition. So what we'll do is we'll use all the three directions. We'll make pieces on all the three directions. But what we'll do is, as we cannot make equal number of pieces, like earlier we had 8 into 8 into 8 or 5 into 5 into 5. But what we'll do is we'll factorize 100 and we'll find out the factors and we'll make three numbers from it, such that the three numbers cannot be equal but will be next to equal. It can be the next possible case to equal. So what can be the factors? 5 into 5 into 2 into 2. So with this, what will make? We'll make four numbers such that they will be almost equal. The next case after equal. So we have 5 into 5, that will be giving 25, into 2 twos are 4. So it's not equal, but it is next possible case to equal. So again, minus 1 will have 4 plus 3, that will be 11. So here, whenever there is a question which is not a perfect cube, we'll factorize that number, and with the factors, we'll make three numbers such that the three numbers are closest to each other, or else, in other terms, we can say that the difference between the three numbers will be less. It should be minimum. So one more question we have: 150 pieces, minimum number of cuts and maximum number of cuts. So for maximum we have 150 minus 1, 149. For minimum we'll have factors as 5 into 5 into 2 into 3. So 5 into 5 into 6. We have 150. Now minus 1. So 4 plus 4 plus 5. That will be 13 cuts. Now the reason to make equal number of pieces, or if we cannot make equal number of pieces, what we'll do, we'll find the next possible case that is closest to equal is when the number is not a perfect cube. So we'll have to make equal number of pieces on each direction. But why we have to make equal number of pieces? In case of cube, that would be easy, that will be 5 5 5 or 6 6 6 or 7 7 7. But in case if it's not a perfect cube, then why we'll have to make it equal is because, let's take an example, 324. So the number of factors here are 2 into 2 into 3 into 3 into 3 into 3. So these are the factors. So by visualization we can see 2 twos are 4, 3 threes are 9, and 3 threes are 9. So 4 into 9 into 9, we have 324, and the number of cuts will be minus 1. So 3 plus 8, that will be 19 cuts. But what mistake we made here? We did not made equal number of pieces on each direction. The major condition used here is that we'll have to make equal number of pieces, or the next possible case that is closest to equal. So here what is there? 9 and 9 are equal, but 4 and 9, the difference here is huge. So what we'll do is we'll make another case, that is 3 twos are 6, 3 twos are 6, and 3 threes are 9. So again 6 and 6 are equal, but 6 and 9 we have less difference here, and we'll check the number of cuts, that is 5 plus 5 plus 8, 18. So minimum is 18 or 19? Minimum is 18. So this is a difference, and this is the major concern why we use equal number of pieces on each direction. So whenever you will be solving questions that when the cuts are made in two directions or three directions, please make sure to make equal number of pieces or equal number of cuts in two direction and three direction question. If it cannot be equal, try to make the next closest possible, which will be closest to equal. And to have that, very simple, the difference between two numbers should be minimum. And through that only you will be getting the condition of minimum. So we have done the part where pieces are given and we had to find cuts. Now in major cases they will give you cuts and you will have to find pieces. For example, let's say they had said 18 cuts. From 18 cuts you will have to make maximum or minimum pieces. So we have again three direction and we have one direction. Now the case here will be vice versa. It will be reversed here. Let's say 18, we have to divide equally on three direction. So 6, 6 and 6. It will not be 18, 18, 18. Total 18 cuts are there and we have to distribute in three directions. So 6 cuts and 6 cuts. Now from cuts to pieces, we'll have plus 1. So we'll have 7 pieces and 7 pieces. 7 to 7, 49 into 7, 343. And if I make 18 cuts in one direction, I will be having 19 pieces. So in the cuts case, we had minimum in three direction and maximum in one direction. Now in pieces case, we have maximum in three direction and minimum in one direction. Let's take one more case, that is 24. So we'll equally divide 24 in three parts, that is 8, 8 and 8 plus 1. We have 9 into 9 into 9. So we'll have 729, or 24 in one direction will have 25 pieces. So this is the pattern where you can use this type of logic to find out cuts and pieces. Now in pieces, please remember that they will not be giving you more than 24 cuts, because after 24 the cuts, the number of pieces will be crossing more than thousands. So the question will be asked till maximum till 24. Now in this, if they ask you 19, so please do not factorize 19 because it is a prime numbers. But in this case, what you will do, you can equally divide it. If it would have been a multiple of 3, it would have been 6, 6 and 6. But the question here is 19. What you will do is you will make 1 into 7. So 6, 6 and 7 almost equal, plus 1. We'll be having 7 into 7 into 8. So this is the pattern if you cannot distribute the cuts in equal number of pieces. So we have done here the basic part on cuts and pieces, and after this whatever we'll be studying, it will be starting from cuts and pieces only. So please try to randomly take any number of for cuts and for pieces and make sure to do at least 10 questions of each. Find out cuts and find out pieces. So thank you. In the next part of cubes, we'll be studying the face paint.